You've got Rory at Actuonics. Today I'm going to talk about how to perform application-specific cycle testing. Common question we get is, what is the life of a particular model actuator? While we can provide an estimate if enough information is provided on the application and usage, we always recommend customers validate life by performing application-specific life testing. This type of testing can help identify unexpected loading or other issues in the target application. Things like stall conditions, impacts and vibration, additional loading from friction, or binding in mechanisms and linkages. Sometimes this type of testing can be conducted using your application's own controller, but if this is difficult to implement or too early in the design process, using an Actuonics timer relay or controller may be a good way to perform this type of testing. Install the actuator in your target device or application. Try to conduct the test at an ambient temperature and humidity that would be average for your application. You can repeat testing later at extremes of expected if your average conditions test is successful. You can also adjust your test timing to speed up testing, but keep in mind some actuator models and operating conditions may be more sensitive to increased duty cycle operation, which could potentially skew your test results. Now we have some different testing methods for our different type actuators. If you're using one of our limit switch actuators, we recommend the timer relay. It's simple to wire up and requires no programming and only simple configuration. If you don't have wire, you can cut up one of our S extension cables. Now to get started, set the extend time and retract time by pushing the buttons on the front of the timer relay. Include the amount of time it takes to complete a full stroke and how long you want the actuator to wait at the limit switch between changing of direction. For example, if it takes 10 seconds to extend and you want it to stay and extend for another 10 seconds, you would set the time for 20 seconds. Now for feedback type actuators, you can use our LAC control board. Connect DC power to the LAC's plus and minus terminals. The voltage you select should match the rated voltage of the actuator, 6 volt or 12 volt. Connect the actuator to the 5-pin terminal. Ensure the yellow wire is aligned with the pin marked yellow. Now you can connect the USB cable between the LAC and your computer. Now if your software download doesn't include the cycle test utility, you can send an email to us at sales@actuonics.com and we will send you a copy. Open the software, enter the extend and retract delay times similar to how we did on the timer relay, and click start to begin cycling. For actuators with internal controllers, which are our -I or -R units, we recommend using a servo tester with the cycle test function, or connect an Arduino controller and program a simple cycle sketch. You can use the built-in Arduino servo library with the write microsecond functions. Use a while loop to loop your code. Use write microseconds to set the target position. Use a delay function to set a time like we did with the timer relay. And set another position with write microseconds and then another delay. Now for monitoring your tests, if you only need a rough measurement, you can record the start date and time and check for failure once a day as your testing progresses. Record the failure date and time when it occurs, and then calculate the number of seconds that have elapsed and divide by the cycle time. Remember to sum the two settings of your timer relay, as that is a full cycle. Your count will only be accurate within 1 day's worth of cycles, so this may be an issue depending on how long you expect this to last in your application. For a more accurate count, you can use a counter and magnet switch. Mount the magnet and switch so that the counter increments once per cycle. When the actuator fills, the count will also stop, and you'll have that recording which you can check and record. Now for performance verification, use a benchtop power supply if you have one, so that you can monitor current draw during the first few cycles. At the full extend and retract positions, you should see the actuator current go to 0. If it doesn't, you may have to increase the timer delay or refer to the actuator datasheet to ensure you have selected the correct gear ratio for your application. For the limit switch to function on the S-type actuators, the applied force must be less than the backdrive force given on the datasheet. If that looks okay, check your mechanism and linkages to make sure they're not preventing the actuator from reaching full travel. You can use your measured current to estimate the force from the current versus force chart on the actuator datasheet. Increasing the gear ratio can sometimes provide better life in some applications. If you measure the average current and force during the extend or retract movement, and you find it exceeds the peak efficiency point on the datasheet, repeat your testing with the next higher gear ratio option to potentially improve your cycle life. For our brushless models, the S20 and the P8 ST models, use the TIC T825 controller to cycle the actuators. Connect power, the actuator, and USB to the tick. Configure the tick on the computer using the tick software and verify it is performing as desired. Edit the cycle test batch file so that the tick serial number matches the one shown in the tick software. Edit the delays as you like, close the tick software, and run the edited Windows batch file. Make sure to set Windows so it doesn't go to sleep, and if your actuator isn't completing a full stroke in your application, you may need to edit the tick configuration further, or choose a higher gear ratio model. Unfortunately, the current measurement method for load checking doesn't work on this type of motor. With the actuator removed, you may be able to use a load cell or fish scale to actuate and measure the force requirement of your mechanism. And that's it. I hope this helps you set up your life cycle testing in your application.